Hi there. Welcome to this lesson on Pure Mathematics 1. We're on Chapter 2, Quadratics, and we're up to 2.4, Sketching Quadratic Graphs. We'll look at how you sketch a quadratic graph in a moment, but first of all, a reminder. Quadratics are functions that can be written in the form ax squared plus bx plus c. All quadratics have the same shape, and that shape is called a parabola. There are two possibilities. The leading coefficient, the coefficient of x squared, if that's positive, you'll have something like plus 3x squared. It doesn't matter about these numbers, the minus 5 and the minus 4, they could be anything. But if a is positive, then the shape will be a right way up parabola. If a is negative, then you have something like minus 2x squared. Again, it doesn't matter about the other two terms. If that's a minus, then you'll have an upside down parabola. The larger the value of a, the steeper the graph becomes. So for example, if you had f of x equals x squared, it would look something like that. Using axes with the same scale, f of x is 2x squared would be a little bit steeper. F of x equals 5x squared, steeper still. F of x equals 100x squared, starting to get very steep indeed, but they're still all parabolas. They're all the same general shape. How do we sketch a quadratic? The key word is sketch. If you have to sketch a curve, you don't draw a scale, you don't draw accurate axes. The general shape should be right, and key points should have their coordinates shown. There are three sets of points that matter with a quadratic, and you should try and calculate these, unless the question tells you that you don't need to. We'll do an example to see how all of this works out. So let's say you had f of x equals x squared minus 8x plus 15. The first thing is plus 1x squared. So it's going to have that shape. It'll be a right way up parabola. The first thing to calculate, because it's the easiest thing to calculate, is the crossing point on the y-axis. Now the y-axis, it's also known as the line x equals 0, because everywhere on the y-axis, x equals 0. The y values change, but the x values don't. They're 0 everywhere. Now what that means is, if we want to find the crossing points on the y-axis, we just have to let x equals 0 in the function. So substituting in x equals 0, we get 0 squared minus 8 times 0 plus 15, which gives us 15 in total. Second thing we do is find the crossing point on the x-axis. This is always slightly trickier. Now the x-axis is the line y equals 0, because y equals 0 everywhere on the x-axis. That means to find the crossing points on the x-axis, we have to let y equals 0 in the function, or let f of x equals 0. That'll give us 0 equals x squared minus 8x plus 15. And in this instance, it factorizes, as you can see, into x minus 3 times by x minus 5. Now this has to equal 0, which means one of the brackets has to equal 0, which means either x equals 3 in the first bracket or x equals 5 in the second bracket. Okay, summarizing what we've done so far, crossing point on the y-axis will be at 15, two crossing points on the x-axis, one at 3, one at 5, and we could draw a pair of axes now. You'll notice there's no scale, it's not drawn accurately, but we've labeled that point 3, we've labeled that point 5, and on the y-axis we have 15. The last thing that we should try and do is find the coordinates of the minimum point, the point at the lowest point on the curve. To find it, whether it's a minimum or whether it's a maximum, makes no difference. Either way, we complete the square. So what we were doing in the last lesson. Now to complete the square with this function, we get x minus 4 squared, take away the 16 we don't want, plus the 15 we do want. That gives us x minus 4 squared minus 1, tidying this up. Now, important logic here. Pause and just make sure you understand what's going on. The reason for rewriting the function in this form, using completing the square, is because the squared bracket has to be greater than or equal to 0. Something squared can't be a negative number. It's got to be something which is positive. That means if you want to find the minimum value of this function, the minimum value will be when this bracket squared is equal to 0, because that's the smallest it can ever be. It can't be less than 0, it can't be negative, because everything squared is a positive number. To find the coordinates of the minimum point, you have to think about two things. First of all, what value of x will make this bracket equal to 0? Well, if x is 4, then it will equal 0. So the x coordinate for the minimum point is 4, because 4 minus 4 is 0. That's the smallest value the function can take. The y value, or the value of the function, is what you've got left when this equals 0. Now you'll have 0 take away 1. 0 take away 1 is minus 1. So the minimum value of the function is minus 1. And that is where x equals 4. It's very easy to get confused on this. So to find the minimum point, we set this bracket to be equal to 0, because that's the smallest it can be. It equals 0 where x is 4. And when it equals 0, all we have left is minus 1. That is the minimum value of the function, which is why we have the coordinates down here, 4 minus 1, for the minimum value. Okay, time for you to have a go yourself. So this time we've got f of x equals x squared minus 5x plus 4. Try and do the same as we did then. Pause the video and come back when you're ready. Okay, we'll have a look at this together. So the first thing that we do is find the crossing point on the y-axis. That's when x equals 0. If x is 0, we've got 0, take away 0 plus 4. So the crossing point on the y-axis will be at 0, 4. If x is 0, y is 4. Second thing we do is find the crossing point on the x-axis. That's where y equals 0, or f of x equals 0, which gives us 0 equals x squared minus 5x plus 4. I think, again, that does factorize, this time into x minus 1 times x minus 4, which gives us two crossing points on the x-axis. One at 1, 0, putting x equals 1 in this bracket, and one at 4, 0, putting x equals 4 in this bracket. We find the turning point by completing the square. Now, to complete the square this time, it's a bit more fiddly. A half of 5 is 5 over 2, so we'll get x minus 5 over 2 squared. We'll get a 25 over 4 we don't want, a plus 4 that we do want. A bit of fraction work tidying those together, which gives us x minus 5 over 2 squared minus 9 over 4. Now the really important logic that does trip a lot of people up. The minimum point is where this bracket equals 0. Because it's something squared, that means it's never going to be negative. Because if you square anything, you'll get a positive number. So the minimum value is when x equals 5 over 2. Because that will make the bracket equal to 0. If the bracket's equal to 0, all we've got left is minus 9 over 4. And that is the minimum value of y, the minimum value of the function. So the minimum value of x is 5 over 2. The minimum value of y is minus 9 over 4. That gives us the coordinates of the minimum point. So coming to do the sketch, the crossing point on the y-axis is at 0, 4. Two crossing points on the x-axis, 1 and 4. And the minimum point is 5 over 2 minus 9 over 4. Putting all of those into a sketch will give us something like that. Again, there's no scale. It's not drawn accurately. That point is at 4. That point's at 1. That point is at 4. And we've labeled the minimum point, and we've labeled the graph itself. Okay, one more example. And I should warn you, this example is not a little bit harder. This example is much, much harder in several ways. The first way is that you're going to have minus in front of the x squared, which means it's a wrong way up parabola. Because of that, completing the square is more difficult. When you try to find the crossing points on the x-axis, those are more difficult because this does not factorize. So a few warnings. It is quite hard, this question. Have a go. Pause the video. Come back when you're ready. Okay, if you manage to do all of this, then you fully understand this topic very well indeed, but I'll go through it with you. First of all, we find the crossing point on the y-axis because it's the easiest thing to do. We just let x equal 0. Now, if x equals 0, we've got 0, take away 0, minus 3. So the crossing point on the y-axis is at 0, minus 3. Then we find the crossing point on the x-axis. Well, that means we need to let the whole function equal 0, y equals 0, or f of x equals 0. I think the first thing I would do with this is, in a sense, move everything to the other side, or multiply by minus 1. Just looks a bit more normal if you write it like that. So 0 equals 2x squared minus 4x plus 3. It's the same equation to solve. It's a different function, but it is the same equation that would be solving. You hope it's going to factorize. It doesn't. So this time we have to use the quadratic formula to find the two solutions. Using the quadratic formula gives us this, and in the square root we have 16 take away 24. Now that means in the square root we've got minus 8. So we've got another problem. You can't square root minus 8. What does that mean for this quadratic? Well, what it means is there are no solutions to what we were trying to do. We were trying to find where the curve crossed the x-axis. There are no solutions for where it crosses the x-axis. That means it doesn't. The curve never crosses the x-axis. What does that mean? So we haven't found out very much so far. This is the function. We know it's a wrong way up parabola. We know it crosses the y-axis at minus 3. And we know there are no crossing points on the x-axis. Now, if all of that is the case, there is only one thing it can look like. It must be like this. It's a wrong way up parabola, crosses the y-axis at minus 3. It never reaches the x-axis, so it never crosses it. Nevertheless, we can find the coordinates of what is now the maximum point. So the maximum point on the curve. We still use completing the square. That is awkward this time. So 4x minus 2x squared minus 3, all I've done is just change the order so that it's the normal order for a quadratic. What are we going to do with this minus 2? The easiest thing to do is factorize. So take minus 2 outside the brackets. That'll give you x squared minus 2x inside the brackets, and then the minus 3. Now, if you've done that, the rest is relatively straightforward. We complete the square with the bracket in the normal way. That'll give us x minus 1 squared, take away the 1 we don't want, put all of that inside large brackets, then multiply out those brackets. That'll give us minus 2 into x minus 1 squared. Minus 2 times the minus 1 is plus 2, and we've got the minus 3 tagged on the end. Tidy up these two numbers. That'll give us minus 2 into x minus 1 squared, take away 1. The logic is slightly different this time. We're finding the coordinates of the maximum point. So there isn't a minimum point. What it says here in the question is actually wrong. There is no minimum point, but there is a maximum point. To get the maximum point, we want this to be as small as possible. The minus 2 means we are going to be taking away something. X minus 1 squared will always be positive. So we'll have minus 2 times something positive. Minus 2 times something positive will be negative. Now, the maximum value of the function is where what we're taking away is 0. Because we want to take away as little as possible. So the maximum value is where this bracket is equal to 0. That'll happen where x equals 1. So the x value at the maximum point will be 1. That'll make all of this 0. All we'll be left with is minus 1. That is the maximum value of the function of y. So the coordinates of the maximum point are 1 for x, because that'll make the bracket 0, minus 1 for y, because that's all we'll have left when this whole term equals 0. Bit confusing, that. Now that we know the coordinates of the maximum point, we can go back to the curve and we can write in the coordinates there. It'll be 1 minus 1. Okay, that is the question finished. That is the lesson finished. If you have the textbook, turn to page 30 and have a go at exercise 2F. Thank you very much for listening, and cheerio.